record.
Okay.
And share. Pull that up. All right, so here's yet another method to solving quadratic equations. This is by square rooting. And like I said yesterday about the quadratic formula, that will work every single time, but there are easier methods that are worth trying to learn so that you know, you get your work quicker and possibly more accurate. Okay, so first of all, square root. The square root of a number is the factor when multiplied by itself gives the original number. Okay, and you know, we've talked about where if I say what's the square root of 9, everybody says 3 because you know what square root is. However, one thing you might not know is that a square root has a positive, and we did talk about this a little bit with functions, and a negative root. Whoops. Because, and I'm gonna, so square root of 4 is positive and negative 2. Because positive 2 times positive 2 equals 4, but negative 2 times negative 2 also equals 4. So there are actually 2 roots for every number. Now, the principal root is the positive. That's the one we use most of all because if you're talking about the length of the side of a square, you can't have negative 2 units. It's only 2. But there are 2 roots. And like yesterday with the quadratic formula, this was in the quadratic formula, that square root, not square root, but the plus and minus, that represented the 2 solutions, a positive one and a negative one. Now, one thing you got to keep in mind, it's not negative over positive, it's just positive over negative. So that's what the symbol is. In word problems, sometimes just the positive root is used. So when to solve by square rooting. So if you see this, you should automatically go to square rooting just because it's way easier. If it's a binomial with a squared term and a constant. So if it's only a squared term and a constant, so if it's like x squared minus 4 equals 0, it's a binomial because there are 2 terms. All you have is a squared term and a constant. This could be 3x squared minus 4, but you don't have like plus 2x. It can't be like 3x squared minus 4x. That can't be solved using square root. Only if it's a squared term and a constant. Or if the trinomial is a perfect square trinomial, and we'll talk about that in a minute. Okay, so when solving by square rooting, what you have to remember is squares and square roots undo each other. So before we go on to all of this up here, perfect square trinomial pattern, we're going to do a few examples. So the first one says solve the following. So I have 2 terms. I have a squared term and a constant term. Solving by square rooting is the only one that you don't have to have equal to 0, because in order to solve this, all I have to do is undo that square by square rooting. If I square root the left, I have to square root the right. And you have to remember that the square root of 9 is positive and negative 3. So you could technically do this by the quadratic formula. Move that over. And then you have this as the trinomial where A is 1, B is 0, and C is -9, and then plug that in. And you can see that it's way easier to solve that one by just square rooting both sides. Same thing with number 2. You have a squared term and a constant term. So all I have to do is undo that square by square rooting both sides. Square root of 25 is positive and negative 5. So number 3, what you want to do first is to get the squared term by itself. So divide by 2. So you get x squared equals 16. Square root both sides, so x is positive and negative 4. You could, on number 4, take out the greatest common factor of 3 and then factor. But again, we have a squared term and we have a constant. So I'm going to move that 27 over to the other side to have 3x squared equals positive 27. Divide by 3. So x squared equals 9. Square root both sides. So x is positive and negative 3. Now, even if, I'm going to move that 15 over, so you get 2x squared equals 15. You can even square root decimals because you'll have a calculator. You'll have to round to whatever the directions say round to. So on my notes, I rounded to the nearest hundredth. And so when you do the square root of 7.5, the calculator only tells you the positive one, but it's positive and negative 2.74. Question so far?
No, ma'am.
Okay, so if we look at number 6, it's a little bit different, but what we have is we have something that's squared and then we have a constant. So it still can be solved by square rooting. So the first thing I want to do is get rid of that square root, that square right there. So I'm going to square root both sides. So when I square root that square, they cancel and I'm left with x plus 1. And then the square root of 16 is positive and negative 4. So what this tells me is x plus 1 equals positive 4 and x plus 1 equals negative 4. Those are my two solutions. So subtract 1. So x is 3. Subtract 1. So x is negative 5. And you can see if I put in a 3 here, 3 plus 1 is 4, 4 squared is 16, so that works. And then if I put a negative 5 in for x, negative 5 plus 1 is negative 4, but negative 4 squared is also 16. So number 7, same thing, I want to get rid of that square, so I'm going to square root both sides. When I square root that square, it leaves me x minus 3. And the square root of 49 is positive and negative 7. So I have two problems. I have x minus 3 equals positive 7 and x minus 3 equals negative 7. Add 3 to both sides. So one of my x's is 10. And add 3 to both sides over here. So my other x is negative 4. Now with number 8, square root both sides to get rid of that square. So I have x plus 3 equals, and the square root of 10 is a decimal, so I'm going to leave it as plus and minus the square root of 10. So I have two problems. X plus 3 equals positive square root of 10, and x plus 3 equals negative square root of 10. Now, yesterday we talked about not having a negative under the radical. That negative is not under the radical, it's in front, so that's okay. Now, if I want to leave this exact, I would go ahead and subtract 3, and I'd write that whole number first. So there's one possible answer for x over here. Same thing. These are exact values. If I want them rounded, I would type into my calculator -3 plus the square root of 10, and that would give me about 0.16. Then in the calculator, -3 minus the square root of 10, that would give me about -6.16. Okay. So before we go on to example number 9, let's look back up at the notes and talk about this right here, perfect square trinomial pattern. So back when we were first multiplying these, we would have this kind of a problem, x plus 2 squared. And I said you had to expand on this before you distributed. So you had, that's x squared, that's 2x, that's another 2x, and that's 4, and then when you combine, you got x squared plus 4x plus 4. This right here is called a perfect square trinomial because it can be written like that. Now, the way you can tell if a trinomial is a perfect square trinomial and can be written like that is, if you look at the example here, if you can half this number and then square it and get that number. So notice, this last number is half of b squared. So half of 6 is 3. 3 squared is 9. So it is a perfect square trinomial that can be written like this. Another perfect square trinomial, x squared plus 10x plus 25. If I half 10, I get 5. 5 squared is 25. So the number that's used in both of those is 5. So I would write this as x plus 5 squared. Another one, x squared minus 12x plus 36. Half of 12 is 6. 6 squared is 36. This is a perfect square trinomial. It would be written as x minus 6 squared. So, do you have a question about how to tell if it's a perfect square trinomial?
No.
Okay. So, now let's look at example number 9. Now, yesterday we learned the quadratic formula, and we learned that we could plug anything into the quadratic formula. But another trick is you can see if this trinomial here is a perfect square trinomial. So half of 6 is 3. 3 squared is 9. It is a perfect square trinomial. So I can write this as x plus 3 squared, because half of 6 is 3 and 3 squared is 9. Then I can go through, I can cancel that square by square rooting both sides. And I have x plus 3 equals positive 5, and x plus 3 equals negative 5. So one of my solutions is x equals 2. And the other solution is x equals -8. Okay, so let's look at number 10. So I'm going to check to see if it's a perfect square trinomial. Half of 4 is 2. 2 squared is 4, so this is a perfect square trinomial. If it wasn't, then you'd go ahead and do the quadratic formula. But since it is, I'm going to write this as x minus 2 squared equals 36. And this sign and this sign, those signs match. So then I'm going to square root both sides. So I have x minus 2 equals positive 6. X minus 2 equals negative 6. Add 2. So one solution is 8. Add 2. The other solution is negative 4. Okay. So then we look at number 11. Half of 14 is 7. 7 squared is 49. So yep, it is a perfect square trinomial. So I'm going to write this as x minus 7 squared equals 30. Square root both sides. 30 is not, square root of 30 is not a whole number, so I'm going to leave it like that. So one of my answers, x minus 7 equals positive square root of 30. X minus 7 equals negative square root of 30. And if you're going to go straight to the calculator, you have to, after you type in square root of 30, before you add 7, you have to hit equals before you add 7. Otherwise, it'll do square root of 30 plus 7 or square root of 37. So one of the answers is about 12.8. Nope, 12.48. And the other one is about 1.52. Now, I'm going to do a couple more examples. What if we have x squared plus 6x minus 8 equals 8? Okay, so we want to check to see if this is a perfect square trinomial. Half of 6 is 3, but 3 squared is 9, not 8. So that's not a perfect square trinomial. We have what's called completing the square, which means we're going to make this a perfect square trinomial. What we have to do first is move the 8 over. So 8 plus 8 is 16. And notice what I did was I left a blank here, because what we're going to do is we're going to make this a perfect square trinomial. The way we do that, half of 6 is 3. 3 squared is 9. So I would write that as plus 9. That right there is a perfect square trinomial. But the catch is, if I add 9 to the left-hand side of an equation, I have to add 9 to the right-hand side of the equation. So now I have this perfect square trinomial, which is x plus 3 squared. 16 plus 9 is 25. And now it is exactly like number 9, square root both sides. Solve. Okay. All right, let's do another one. Okay. So you can see it's obvious that this over here is not a perfect square trinomial. You can use the quadratic formula. Sometimes it's easier to just complete the square. But the reason that I wanted to show you completing the square is because it puts the equation into a specific form for graphing, and we'll look at that sometime this week. So it's not a perfect square trinomial, so I'm going to make it one. I'm going to move that 2 over by subtracting 2. When I move that 2 over, I leave a space, and 1 minus 2 is -1. So now I have to complete that perfect square trinomial on the left-hand side. And the way I do that is I half 10, which is 5, and then I square it. Half of 10 is 5, 5 squared is 25. But remember, if you add 25 to the left-hand side, you have to add 25 to the right-hand side. Now this x squared minus 10x plus 25 is a perfect square trinomial that I can write as x minus 5 squared. And -1 plus 25 is 24. And now it's just like the others. Square root both sides. So you have x minus 5 equals positive and negative square root of 24. So my two problems are x minus 5 equals positive square root of 24, and x minus 5 equals negative square root of 24. So I have 5 plus square root of 24 and 5 minus square root of 24. So I'm going to type that into my calculator here. So 5 plus square root 24 equals, and that's about 9.90. And then 5 minus square root 24 is about 0.10. You have any questions about completing the square?
No, ma'am.
Okay, well, that's all I've got for you. Everything good then?
Yes, ma'am.